Welcome, everyone, and thanks for joining us. Across enterprises and MSSPs alike, analysts are challenged by the scale and speed with which today's threats are outgrowing traditional workflows. What we're exploring in this conversation is how AI helps teams reclaim control by turning their existing expertise, processes, and tools into something that can scale. We'll talk about how deterministic decision models capture the judgment of your best analysts, and how agentic workflows accelerate investigations without sacrificing trust. Well, welcome. Today, we're going to talk about the opportunity around AI in the SOC and the need to ground it with trustworthy AI. So first, I'd like to welcome Darius. Nice to meet you, Darius.
Nice to meet you, David.
Yeah, and tell me, how did you get into cybersecurity?
It's actually a funny story because I had no idea cybersecurity was a career when I was back in high school, college. So I mostly worked as a sysadmin for an email service provider. After that, I finished up college and was looking for a job as a sysadmin. And a friend told me, why don't you go in cybersecurity? And I said, okay, that's a thing. And then I started self-learning for half a year and then applied to some jobs and got an offer to work for an MSSP.
Great. And so tell me about your first role at that MSSP. What did you do?
It was actually the very beginnings of the MSSP. It was set up in a large enterprise, but it was the first time that department was being built. I was involved in the initial engineering side of things, setting up the tools, creating some of the detection rules, building up the processes, and then moved into the operational sides where we would have to monitor and investigate some alerts. Also had to build up phishing assessment infrastructure for particular services. So a bit of everything.
Yeah, you had a very broad role. And then after the MSSP, you joined Arcanna?
Yes, precisely.
Got it.
And Arcanna was appealing to me because as a startup, it has a different structure than a corporation. So found it more appealing. So yeah, then I jumped.
And what do you do for Arcanna today?
Currently, I'm a lead solutions architect, which is a mouthful. I basically do presentations, demos, including the technical preparation for them, data sets, training models, things like that. And also work for POCs with our customers and in production consultancy, helping them keep things in order. So a bit of everything, but I'm mainly the main user of the platform that we're building.
Yeah, so you truly are a jack of all trades who has a broad experience across the whole security operations center environment. So over time, you've gotten to learn a lot about different client SOC environments. Why do they typically come to Arcanna, and what are the different types of companies that you see?
Well, I would split our customers in two.
Okay.
We have our large enterprise customers, and then we have MSSPs. And there are a few differences between these two types of customers. The common thing is that they both have security operations analysts monitoring alerts, but the structure is a bit different. So if we're talking about, say, an MSSP, they would have to deal with hundreds of customers across the world, different teams. And while they do have data from the customers, they don't have all of it. So most of their activities revolves around detection, initial investigation, but then they need to pass it as soon as possible to the customer. For them, the most important thing is to do it, the response time since the alert appears, until it escalates, the customer should be as short as possible. And that's what we try to achieve with them. Now, within an enterprise, they're responsible for their own security. They would have an internal department, they would be a cost center, so they are limited by a budget as well. And what they're looking for mostly is making sure they have vast detection coverage while balancing that with the team that they have. And also trying to correlate the sparse data sets that they have. That's a common challenge. They do have all the data, but it's not all in one place. So a lot of work is on getting the data in one place and then trying to expand the detection coverage as well.
Yeah, so in both cases, MSSPs and enterprises need to scale operationally with limited increases in headcount and budget. So given that, what approaches and technologies are SOCs using to scale effectively?
So there are the traditional approaches where most of them would have a SIEM and a SOAR. In the SIEM, you would deploy detection rules, which you could fine-tune to make it more efficient, but that has its limits. If you do it too much, you lose some of the coverage. If you don't do it at all, you would have too much noise. So there's a balance to strike there. And then within a SOAR, that's usually where you do correlation and enrichments with different systems. So you would go out and get additional data, put it together, have some conditions there, and that's very helpful, but it does have its limits. You cannot set up thousands of if and else conditions, and at some point you still need to pass it to a human to do some more dynamic interpretation.
And so it seems that a lot of companies are looking to AI to help with this particular challenge. So how can AI be used to help at this step?
There are different kinds of AIs, and I think nowadays the AI that people are thinking about is the LLM type, the large language model, Gen AI type of models. And they are very useful and powerful for things like syntax, right? Now everybody's writing code in English. That's useful to essentially do queries more easily. The LLM can generate a query for a system. And that essentially helps with data collection. And it's also very useful for reporting. However, when it comes to decision making, we don't think that's the right approach.
Why is that not the right approach? What's the issue with having a large language model make decisions?
To put it simply, an LLM with the same input could give you different outputs. It's not consistent. And in decision making, you would expect it to be consistent with that. Then decision making is based on the policies, the processes, the data specific to a company, the knowledge and intuition of their people. And those things are not in the training set of the LLM. The LLM was trained on general internet data. And it's not suitable to make very particular specific decisions.
Yeah, so you mentioned that there's a second approach. Can you tell me about that approach and how it's different than the LLM approach?
Yes, the second approach is to use decision models. And just to shed some light on what decision models are, they're deep neural networks, which are trained on premise using only the customer data, the data in the customer's environment, and their experts' knowledge. So those are very specialized in that particular environment. And just to maybe give an example, oftentimes IT departments would act like they're threat actors for some reason. Maybe it's easy to use, maybe they want to bypass some restrictions, but they would run an update from the temp folder.
Sure.
And that doesn't look normal. So in the general knowledge of the internet, that's malicious. However, any person in the SOC knows, okay, that's IT, that's how they do things. So there's a difference in knowledge there that's captured by the decision models, but it's not captured by the LLM. Maybe that's a bit more helpful with
Yeah, absolutely. I think what you're getting at is the notion of consistency or reproducibility. So why is the reproducibility of a decision model more important than the raw intelligence of an LLM?
That's because in decision making, we are looking for the same decisions given a specific input. And while LLMs are more powerful in raw intelligence, because of the nature of data they're trained on, they would not yield the same result. And it is not reliable nor trustworthy.
So you mentioned that decision models are different than Gen AI, for instance, that they run on premise. What are some other important differences between a decision model using AI versus a generative AI approach in the Security Operations Center?
So a big one is resource usage as well as speed. The decision models can run on-prem, only on CPU, RAM, and some storage like SSD, while LLMs need a dedicated GPU or TPU. Anyway, expensive hardware if you do it on-prem, or expensive bills to the cloud. So the use cases are a bit different. When you have $50,000 per day in a large environment, you don't want it to trigger generative AI 50,000 times.
Yeah, that would be some very expensive queries.
And it will take longer as well. So A decision model will provide you the decision on all those 50,000 in under 5 seconds each. Well, that's not possible with the other one. So there needs to be a clear distinction on which use cases each one of these approaches tackles.
It does seem that the decision models in generative AI do have certain places in the security operations center. So can you give me an example of where a decision model makes sense and where maybe generative AI would make sense within the security operations center?
Yes, definitely. And the truth is that to obtain something end-to-end, you need to use both. You need to make use of both. So let's take an example, something that's familiar to most people. Let's think of a phishing email. It can be reported by an employee or from your email gateway. And then initially what you'll have, you'll have your sender, receiver, some email headers and attachment. And oftentimes you can get rid of most of the spam emails or newsletters from there, leaving you with potential phishing ones. And that's something that the decision model can do. It can do the initial triage for that, leaving you with the phishing emails, the likely phishing emails.
Got it.
But now, okay, we have a phishing on our hands. Do we have any impact?
You need to do an investigation.
You need to do an investigation. But that investigation will depend on what's in the initial email. It's very hard to hard code these types of investigation. So in that case, we would create an agentic workflow with a few agents. Let's say you want to find out who clicked the link in the email, or if anyone has. That agent should maybe go and look at the DNS lookups in your SIEM. But then, was something downloaded from there? You need to check some endpoint logs. Was that something executed? If it was found. Those are some other endpoint logs. So you have 3 places in which they need to search dynamically, and the result of each will be, let's say, the investigation result. We don't stop here necessarily, because we still want to ground everything with a decision model. So even though our first decision was phishing, now we have more information. We can send it to another decision model, which will tell us, for example, the level of impact, depending on the entities involved or found, or the type of attack. We could have a true positive, but with low impact, because it's somewhere remote, the user did not have much access, or it could be something critical. The CEO was compromised, right? Or HR. That's one use case in which it ties end-to-end using both decision models and agentic workflows.
Yeah, so it seems that the decision models can really ground initial decisions. And then in the investigation, you can then apply LLMs through agentic workflows. And then you can actually bring the decision models back in to monitor those agentic workflows to see if those are actually grounded as well. Is that
Yes,
right?
because you want everything grounded into what the people there are thinking, the experts there are thinking.
Yeah, that's a really good point. And so let's actually talk about how Arcanna's decision models work and what goes into them.
All right, so we established that these are deep neural networks. Now, how are they getting built?
Yeah.
Well, we'll get some initial data from the customer, and then we'll have the SME, let's say a senior security analyst, tell us, okay, what parts of that data am I actually using when making a decision? And those will become our decision points or the features of the model. So once we have that, we control what data goes in the model. Then the same person will train it, give it examples, and see how it reacts. And by going through a few runs of providing feedback, training the model, seeing how it reacts, we reach a model with high accuracy that's behaving according to the expectation of the SME.
Where the same input gets you the same output.
Yes.
Yeah. So at that point, what happens with the model?
At that point, the model can start being used in production, and it will start providing predictions to the consumer. That may be the SOC, that may be the customer in case of MSSP. But there's also an important part here of how trustworthiness is achieved, because there's a combination of some guardrails that we have and also some traceability that we allow as well. So those are important aspects to make sure everything we do is clear for the consumer.
Got it. And so how is this different than how LLMs are trained?
The LLMs don't require supervision in the whole training process. There are some methods like reinforcement learning from human feedback, where you do get some human feedback, but the base models are not completely based on user training. Now, in Arcanna, these models are solely based on the human training.
And because of that, they're very much unique to each individual organization or MSSP.
100%. And the same behavior from two organizations, the same behavior would yield you potentially two different decisions. So there's no universal truth. Each enterprise will have its own truth and its own expectations.
Yeah, and I guess in a way that makes it quite flexible, where it can fit in with the existing processes that are already in place in a given SOC.
Yes, the process will define how these models are built and how they are trained and what data they need to achieve it.
So coming back to guardrails, what guardrails or validation steps does Arcanna use to ensure model outputs are reliable?
We implemented guardrails at different levels. The first one, although not a direct guardrail, is the first one, which is the decision point selection. Controlling what data goes into the model is the first front. Once we have the model, it will provide us with predictions. And there we have a confidence score, which tells you how similar the current alert is to something in the knowledge base, in the training data. And then we also flag outliers. Say, if you receive an email into a network AI model, it will flag it, hey, this is too different. You need to provide additional training on this one. The analysts will be able to know which decisions to consume and which require more training. And then we also have, we can show you similar alerts from the training set to the current one. So if you have a completely new alert, you will get a prediction. And if you want to track what exactly biased this prediction, you can look at the similar alerts and you can see, okay, so top 10 most similar alerts all received this decision from this analyst, which means this is likely why the model made this new prediction. So you can kind of track back in the history what caused the decision. And if you find any mistakes, you can also correct them, the mistakes from the past, and clean up the model, basically.
So yeah, it really does operate at several layers. So given that, how does Arcanna's approach help SOC leaders maintain confidence and accountability when introducing AI into workflows?
I think traceability is a big part of it. Because these models are trained by their teams with their data, we can show them exactly who trained it and how. And not only that, but also we can provide team insights, meaning how often do analysts agree on the same thing? Let's say 8 analysts look at the same thing, only 6 of them agree. There's something there. Maybe something's missing. Maybe they need more training, or maybe they don't have all the data, or I don't know, it was just not their day. So all these insights that we can provide, how much they agree between themselves, how correct they are versus the final decision, and who trained what, all of this goes into the traceability that managers need to actually be able to trust and deploy this in production.
Okay, so now we're going to turn our attention to the Arcanna platform. And the Arcanna platform is broken into 2 components, the decision layer and the investigation layer. So first, let's start with the decision layer. How does it help analysts make faster, more accurate decisions on alerts?
There are multiple ways in which these decision models can be used. For example, we can talk about alert triage being one use case that's pretty common. We then have alert prioritization. That's very important, especially for MSSPs, where your SLAs will change depending on that priority. And if you leave an initial P4 too much in the queue, you might find that it's a P2 and you're 4 hours overdue. So having the right priority initially is very important. Then response scoping, whether or not you should make a response on a particular host and what that response should be. That's also a very important decision. It's hard to hard code because you'll always get new scenarios that you did not cover. So all of those use cases, and including the team insights that were covered later, are very useful. And these decisions can also be used before or after the analyst, in the sense that this can be used as a guardrail to the analyst. With our largest customer, about 4% of the time, when confronted with Arcanna's decisions, the analysts change their mind. And that's, you don't have to trust the model, you just have it act as a guardrail. However, if the model is accurate for a long time and you're satisfied with the performance metrics we provide, which are in depth, then you can just use that decision. So the usability of these decisions is flexible from start to finish. You can decide how many of them you want to use, where you want to use them, but in the end, it all goes towards it being very accurate and more trusted as time goes on.
So then let's talk a little bit about the investigation layer. How does the investigation layer relate to the decision layer, and how does the investigation layer support deeper analysis, evidence gathering, and reporting?
Okay, so to establish a better distinction between the decision layer and investigation layer, let's think of it this way. If you have the data and you need a decision, the decision layer is the answer. But if we don't have the data, it's not easy for us to get it in traditional ways, then in that case, the investigation layer is more appropriate, where we will be using those agents to gather the data for us. So if we don't have the data, investigation layer is used to get it. Once we have the data, decision layer is used to get that verdict that we all need.
Looking at the value this provides to different people in the SOC, how does the investigation layer reduce the time spent on manual evidence gathering?
It reduces it quite a lot. In recent deployments that we've seen, a threat hunt or IOC search would take a few hours, let's say maybe 2 or 3 hours. With an agentic workflow running, it will finish up in about 10 to 15 minutes. Exactly the same process the analyst would do. Same thing goes for helping out with onboarding new detections, where you have a generic rule which you want customized for your environment. That's a task that the detection engineer would do. Still, maybe spend even more hours than that. You have to design it, test it, modify it again, test it again. So there are different use cases where this can be used, and everywhere they will get this time saved, simply by virtue of not needing for them to think about the syntax, and also by the ability to scale agents. You can deploy as many agents as your hardware permits, while it's harder to scale humans.
So turning to another aspect of the investigation layer, how does it improve things like report quality, consistency, and speed? Reporting is very important.
Reporting is very important, and it's also very troublesome for most people. Like when I worked as a SOC analyst, the last thing I wanted to do was write reports. I'd have a markdown file, but the customer wouldn't take markdown. So a lot of time wasted on that. And I would say even a lot of information was not included. Analysts are not so thorough with documenting what they saw or found, although it may be relevant. So when we're doing reporting with agents, we can have a clear structure that it will follow, and we can include as much information as we want to. So that's also a really big help in operations.
Yeah. So when you take those two together, what does this mean for SOCs trying to scale investigations without adding more analysts?
I think this, first of all, would allow existing analysts to specialize into complex things that are done on demand, custom detection, creation maybe, or threat hunting, reverse engineering, forensics, whatever they like, to do some pen tests. Basically allow them to develop their technical skills in more creative scenarios, while the boring stuff that could not be automated in the past can now be automated, and they will just be the supervisors. They will validate the decisions, review some things, but the nitty-gritty of those day-to-day operations would be almost completely automated.
And at the same time, all of that new knowledge that they've brought in through this time saved gets reinforced back into the decision models.
Absolutely. Instead of spending your 6 hours a day in operations, in those 6 hours, you could create new agents. You could create new tools that these agents can use. You can think of novel ways in which to use them or to decrease the risk for the organization in any way.
So let's talk about some actual Arcanna clients. What types of measurable improvements or what types of exciting things do you see them using or creating?
So the main benefits will be reduced response time from, I don't know, maybe 10 minutes, 20 minutes to 15 seconds. Then we would have time saved, because once the model is properly trained and the team will trust the decisions, they no longer need to look over a specific subset of those alerts. If they want to, they can, but if time doesn't allow it, that's simply time saved for them. And overall, it's reducing the risk of the organization. It will work 24/7. It will help you catch those things that the analyst might miss, like I mentioned with the 4% of the time.
Yeah.
It's basically supporting them in different ways, all towards reducing the risk and making sure you can scale without having to drastically increase the headcount. It doesn't need to be linear. You can get twice the customers with the same people, or maybe bring on a few more people.
Yeah, while still maintaining all of the expertise and experience that's embedded within those experts.
Yes.
That's great. Thank you very much. Really enjoyed our time together. Thanks for joining us today. For MSSPs, operational scale is everything. You're expected to deliver high-quality detection and response across dozens or hundreds of customer environments, each with different data availability, different baselines, and different expectations. Arcanna helps MSSPs meet these demands without adding headcount, compromising quality, or sacrificing SLAs. Its decision models provide reproducible, customer-specific decisions at massive scale, while agentic workflows accelerate investigations across diverse toolsets and log sources. The result is a force multiplier for your analysts, faster triage, consistent outcomes, and the ability to onboard new customers without operational strain. With Arcanna, MSSPs can expand their service capacity, maintain quality, and stay ahead of evolving threats using the expertise they already have.